Hello. So this is a question from IIT JAM 2022 mathematics. So this is question number 19. So here the consider the group. We have this two group Q plus and its subgroup Z plus. So for the quotient Q by Z, which one of the is false? So out of this four option, we will have to find the false option, the false one. The false one is the correct option. So that is our question. So how to solve? So we will go one by one. We'll check through these options. So in that case, how can we write this quotient group Q by Z? So we can write it in the form of M by N plus Z, where M by N belongs to this group Q. So these are all the elements of this group, right? So now if we want to find the order of this element, so if we find the order now if we find to order of the element, so we will just multiply these elements nth time. So if you want to add it nth time, okay, to the power n, so it will give us n multiplied by m by n plus of z. Okay, so it will be m plus n z. So it is nothing but this nz is nothing but m plus z, which is also, since m this belongs to this z, so we can write it as simply as z. Okay, so this is the identity element of this group. So what is the order of this element then? So it is coming, the order of this element is n. So we can write it in this way: order of m by n is n. Okay, so this is the identity element of this group Q by Z, and order of this, each element of this group is finite. So this Q by Z, it is an infinite, it's a group of infinite order. Okay, it's an infinite order, and this order of each element of this group is finite. Now suppose I have a subgroup, that is H, which is subgroup of this particular group. Okay, now each element of the group, if I consider this over here as this, now, or if I want to find this order of this each element of this subgroup, so I can write this m1 by n1 plus z. So it will be n1, which is finite, right? So order of each element of this group is finite, of this subgroup, it will be finite. Now we have the option, see that QZ contains a subgroup isomorphic to Z and plus. Now if we consider this, Z and plus. Okay. Now here the identity element is 0 and the order of this element is 1. So only one element of this group is finite, and this order of all other elements will be infinite in this group. So we can say that H, that I mentioned, the subgroup, is not isomorphic to this Z and plus. So we can write it in a more clear format. So H is not, since one of this element is finite and accept all other elements, so only order of one element is finite. Okay, and all other elements will be, order of all other elements will be infinite in this case, and here order of each element is finite. Okay, so we can say that H is not isomorphic to Z and plus. Okay, so in our case, this option A, it is given that it contains a subgroup isomorphic to Z plus, so this is actually the false option. So we will check with other options too. Now we will see with option B also. So what is the option B is saying? Let's check. So there is exactly one group homomorphism from Q with Z to Q plus. Okay, one group homomorphism. So we can write it over here. In case of option B, suppose H is a, we consider a subgroup H of this group, and which is a finite subgroup, and also the order of each element order of each element is also finite of this particular group, and H is a finite subgroup, okay, of this group. So if it is a finite group, it will be cyclic. Okay, then every cyclic group is isomorphic to Zn, okay, which is a subgroup of Q by Z, right? So H, we can write it as H is equal to this Z. Okay, this is a subgroup of H, is also a subgroup of this group, and since it is isomorphic to every cyclic, it will be isomorphic to Zn, which is less than this, which is also a subgroup of Q by Z. So we can write this. Now we have this Q plus. Okay, now only one element is of finite order, and that is the identity element. It will be of finite order, right? Z1, and so we can write it over here, one finite subgroup. So here is one finite subgroup. Okay, so only one element of this finite order, so it is isomorphic. Now we have to find the homomorphism from this Zn2. So you can write this Zn. So we have to find the homomorphism from Zn to this Z1, right? So what we have to find this homomorphism, so this is the greatest GCD, greatest common divisor. It will be n comma 1, and GCD of n comma 1 will be 1, right? So there will be a one homomorphism. This is one sub homomorphism. So what are this statement B is telling, option B, that there is only exactly one group homomorphism. So you can see from here, this option B is correct. This one homomorphism is there, so GCD is 1, so only one homomorphism from Zn to Z, right? So option B is in our case is correct. Now what is the option C? Option C is telling for all n belongs to this natural number. So there exists a G which belongs to this group of this Q by Z quotient group, such the order of G is n. So it is very simple. So from here we can find this order. We have find this order of this particular group. This one is n, right? So this n is finite, and it also belongs to the group of this natural numbers, right? So the order of G is also n, which is also finite and belong to this group of natural numbers. So option C is also correct. Now finally the seeing is that D, the Q by Z, the quotient group is not a cyclic group. So let us check. So Q by Z, if we take this option, this is the option. So Q by Z, if it is an infinite group, infinite order, group of this infinite order, so if it is cyclic, if it has to be cyclic, then it will be isomorphic to Z. So if this infinite order group is cyclic, then it will be isomorphic to Z. Okay, so I have to check whether it is isomorphic to Z or not. Now we write these two things. One is the QZ, and another we have this Z plus, right? Now here, order of many elements. So the order of many elements will be finite over here, not another single element is the same. So order of this group, we'll find that many elements will be finite, whereas order of this particular Z, it has only one identity element, so order of it is 1, right? So it has only one element is finite. So we can say that this group, cyclic group, is not isomorphic to Z. So QZ is not a, so it is not a cyclic group. So from here, so we have already got the correct option. Which one will be the false? So it will be the option A.